Hi all, welcome to today's webinar on Amazon EKS Anywhere. Today we are going to talk about the different use cases that EKS Anywhere is targeted around, as well as take a deep dive into the technical aspects of EKS Anywhere, and we're going to touch upon the product direction and roadmap as well. Moving on to the next slide. So I'm Rama Ponnuswamy. I'm a senior container specialist from the go-to-market team focused on EKS and EKS Anywhere. I also have Lee Lee, who's a product manager from EKS, as well as Gokul Chandra, who is the solution architect focused on containers. I'll be touching upon the use cases and an overview of EKS Anywhere. Lichin will take you through the product roadmap and direction, and Gokul will take us through a technical deep dive and a demo of the cluster setup itself. Moving on to the next slide. From a customer use case perspective, we are looking to support customers that are looking to leverage their existing investments on their data centers whose expiry is not in the near term, as well as to enable customers that are looking to do stricter governance control on their existing on-premises Kubernetes environment, as well as use this EKS Anywhere as a stepping stone to make their cloud journey into EKS at some point. So we're also focused on customers that have regulatory and data residency requirements to be able to run their workloads on particular environments within a particular region or a geo. EKS Anywhere also enables customers that are looking to have reduce the complexity of operating their Kubernetes clusters across multiple environments, both on-premises and cloud as well. We're also providing an opportunity to reduce cost in terms of being able to split your workloads and customize your workload deployment options, as well as giving the customers an option to run a secure and stable open source software that is vanilla Kubernetes. And EKS Anywhere ensures that you get up-to-date secure software, as well as all vulnerability issues that are being scanned are kept up to date within the EKS Anywhere distribution. So moving on to the next slide. So what is EKS Anywhere, right? What does the product entail? So EKS Anywhere at the very least of it is vanilla Kubernetes that is packaged along with a little more bundled components that help you ease your operational effort, as well as accelerate your readiness of production clusters when it comes to running on-premise Kubernetes, right? We also ensure that the security patches are kept up to date and you're able to run a secure, stable version of Kubernetes within your on-premises environment. And EKS Anywhere is also built on the same open source standards that Kubernetes relies on, that gives you lifecycle management tooling options as well. Currently, we enable EKS Anywhere to be deployed on any VMware environment that has vSphere 7.0 and above. And we are looking to support exist bare metal and self-managed compute options as we go forward as well. And Lichin will talk a little bit more about the roadmap direction and what we are planning to do from that perspective. So moving on to the next slide. If you're aware of all the EKS options available currently in the market, you should know that EKS Distro is an available open source option where we enable on-premise deployment for any customers looking to do Kubernetes deployment on-premise. And EKS Distro is the basic binary or basic Kubernetes distribution that powers EKS across all of its flavors, right? And that includes EKS Anywhere as well. So EKS Distro gives you an option to ensure that you have fully patched, security aligned version of Kubernetes that you can run. And EKS Anywhere takes it a notch above that, where we bundle in more components that help you with cluster creation and ongoing lifecycle management of the cluster as well. And we will dig a little deeper into what those components are and what are the technologies that we're bundling in along with EKS Anywhere to make this process easier. Moving on to the next slide. So as I mentioned, we do bundle in multiple components that ease your operational burden when it comes to operating Kubernetes clusters on premise. So as I mentioned earlier on, we currently do have a prerequisite which is you need a existing VMware vSphere 7.0 or above installation in order to be able to deploy EKS Anywhere cluster. So in terms of the components that we bundle in a node operating system. Uh, Currently, we support both Ubuntu and Bottle Rocket as two different options. Going forward, we look to support more options as well. From a CNI standpoint, we also bundle in Cilium, which helps you with your overlay networking needs and as well as networking setup for your Kubernetes environment. We also bundle in a GitOps component, which is basically a Flux controller, which helps you with cluster lifecycle operations, where you can configure a GitHub endpoint, wherein you can check in your configuration files, and based on the changes that you make to those configuration files, the Flux controller will automatically recognize the change and reconcile your Kubernetes cluster accordingly. From a storage standpoint, today we support all CSI compliant drivers, so you are free to use any storage options that are compliant with CSI. But we don't particularly bundle in any component at this point. You are free to use any tool of your choice that is CSI compliant. From a cluster lifecycle management and scaling management, you are able to use both our EKS CTL CLI as well as Flux for your operational ease. We also optionally provide EKS Connector component that you can use to connect your EKS Anywhere cluster back to your EKS Cloud Console, so you get that single pane of visibility from the EKS Cloud Console across your different clusters running across cloud as well as on premises. So these are just the list of bundled packages that we support today. This is not the final list of components that we would be supporting. Going forward, we would be adding a lot more components to ease your operational burden even further. And apart from these components, you are free to use any other component. You are free to integrate EKS Anywhere with any other components that you use today or that you would prefer using. But the only difference is this will not be supported under the support plan. So all of these bits, including EKS Anywhere, as well as all of the components that we bundle in, are free of cost and open source. So any customer is free to download them, install the cluster, and use it going forward. We optionally provide a support plan where AWS would serve as the single point of contact for any support questions related to not just EKS Anywhere, but all of the bundled components that we provide today with the product itself. So moving on to the next slide. As I mentioned, we do provide an EKS connector optional option where you can connect your uh, on-premise EKS Anywhere cluster back to your EKS Cloud Console, so you get the single pane of visibility across all your clusters. And this is applicable not just to EKS Anywhere. You can choose to connect your Kubernetes clusters running across other platform providers as well. So moving on to the next slide, I will transfer it over to Gokul to provide you guys a technical deep dive as well as a demo of the cluster setup. Gokul, over to you.
Thank you, Rama. Let us start with a quick overview on the architecture. EKS Anywhere will create and manage Kubernetes clusters on multiple providers and runs on-premises in the customer data center. This is different from ECS Anywhere we announced earlier this year. Here, both EKS Anywhere control plane and data plane are on-premises, enabling disconnected use case and address inherent limitation from Kubernetes, where network latency between control plane and data plane cannot be too big. Currently, we support creating development clusters locally with Docker and production clusters using VMware vSphere. Other deployment targets will be added in the future, including bare metal support in 2022. The environment in which EKS Anywhere is installed needs outbound connectivity to AWS services, namely AWS Elastic Container Registry, ECR, to pull EKS distro-based images. So EKS distro enables users to run the same Kubernetes distro that is powering the EKS today. The next is AWS S3. This is to retrieve OVA files. These are used for Node OS, and users can clone these templates to vSphere beforehand, where they don't need this connectivity. Soon, we'll be supporting a fully air-gapped install, allowing users to use their own local container registry. All the installation and bootstrap aspects can be driven from the admin machine, which has the connectivity to the target provider in your data center. This creates the end workload cluster on the provider. Optionally, if user is enabling EKS connector for a single pane visualization, the cluster needs outbound connectivity to the EKS endpoint on AWS cloud. Moving on to the next slide. To create an EKS Anywhere cluster, you need EKS Cuttle and the EKS Cuttle Anywhere plugin. The Anywhere CLI is implemented as an extension to EKS Cuttle, which is being used to deploy and manage classic EKS clusters on AWS cloud today. EKS Anywhere supports a GitOps workflow for the management of your cluster. When you create a cluster with GitOps enabled, EKS Anywhere will automatically commit your cluster configuration to the provided GitHub repository, authenticating using a token provided during the cluster installation. And this also installs a Flux GitOps toolkit on your cluster, which watches that committed configuration file. Control plane and data plane can be scaled horizontally, adding more nodes, or vertically, providing nodes with more resources. In each case, you can scale the cluster manually, semi-automatically, or automatically. This is the feature matrix where the CLI can deal with most of the upgrade and scaling aspects for both control plane and data plane, and Flux can handle vertical and horizontal scaling of the data plane. Now, let us see how all these work in real time with a quick demo. In the interest of time, the demo covers aspects like cluster installation, managing cluster with GitOps, deploying workloads with GitOps, and EKS connector in high level. Now I'm transitioning to the browser where we can go through some documentation. EKS Anywhere is open source and all the documentation is publicly available at anywhere.eks.amazonaws.com. The first supported EKS Anywhere provider, VMware vSphere, is implemented based on Kubernetes Cluster API provider vSphere, which is also abbreviated as CAPV specifications. As shown here, the cluster creation involves an admin machine from where the user issues EKS Cuttle Anywhere commands, which creates a temporary kind-based bootstrap cluster that triggers the creation of a workload cluster on the provider, VMware in this case. Once the workload cluster is created, the bootstrap cluster transfers all the cluster management entities to the workload cluster, enabling it to manage itself. The temporary bootstrap cluster is deleted with successful workload cluster install. If there are any issues in the workload cluster install, the temporary bootstrap cluster will be remain active so that like we can debug and get the debug information from the bootstrap cluster. Now, configuration required to create a cluster. EKS Anywhere cluster creation is driven by a single configuration file where users can configure various entities such as control plane, etcd, worker node of the cluster, and other optional add-ons like GitOps, OIDC, proxy, etc. This is a sample template with all the required parameters. Cluster network section, which includes CNI-based configuration, pod subnet and service subnet CIDRs can be provided here to be used with CNI Cilium. Control plane configuration, which includes the number of control plane nodes to be provisioned, the endpoint, which is the virtual IP for HA control plane and machine references to control plane nodes. Data center reference. This map to vSphere data center config, which includes the vSphere information such as data center, server URL, thumbprint for signing, etc. The external HCD configuration. The external HCD configuration, here the HCD members are configured in unstacked topology where the HCD have dedicated machines and are not co-located with control plane components. Kubernetes version is specified here, which plays a significant role in selecting the templates and container images. The last part is the worker node group configurations. Here, these map to vSphere machine configs where users can configure resources like disks, CPU, memory, node OS of the cluster machines, and also SSH keys for accessing these machines. So as said, this is the vSphere data center config, which is referenced by the data center reference here. So here you'll be providing your data center on your vSphere environment, the server, which is your FQDN or the URL of your vSphere environment, the network where the cluster should be created. In secure and thumbprint or for signing authorities, you can use the vSphere thumbprint to sign your certs, and followed by the vSphere machine config, which will be referenced by all three components, control plane, HCD, and also the worker nodes. Here, as you see, you can configure the disk size, the data store, folder, and CPU and memory. Here, there are two important aspects, the OS family. So today, we support BottleRocket and Ubuntu as your node OS systems. So here, users can mention what OS family has to be chosen. The second thing is the template. So the template is the reference to the OVA template that you want to use for this specific cluster. A detailed explanation on the various parameters in the configuration or in this section, along with other additional optional configuration information. Moving on to the artifacts. EKS Anywhere releases OVAs, BottleRocket and Ubuntu and container images with every new release. If there are no templates in the vSphere environment, the automation automatically clones a suitable OVA based on the Kubernetes version and the OS specification in the cluster configuration. Users can pre-clone these supported OVAs as templates in vSphere environment and tag them accordingly with OS and EKSD release, which significantly reduces the time for cluster creation. Information on downloading, tagging, and creating custom OVAs are in the artifact section. Now, let me move to the terminal to show how all this works in the real time. This is the admin machine where I have Docker and EKS Anywhere CLI installed. EKS URL, username, and password are configured as environment variables, and the automation picks these values from the environment variables. Users can use EKS Anywhere generate command with provider to generate a configuration template where the values can be configured. This generates a file with empty fields and the default values. For example, this is the generated file. Here is a populated demo configuration file. This has 3 control plane nodes, 3 external HCD nodes, and 2 nodes. A endpoint is provided which is outside of general DHCP, which will be used for virtual IP for the control plane. Kubernetes version is specified also here. In the data center config, vSphere information is provided. In the machine config, Ubuntu is used as Node OS, and a folder called EKS demo is used where all the virtual machines of this cluster will be created in VMware environment. Apart from the general config, GitOps is configured here, mapping to a repository EKS demo cluster. With this, we can start creating the cluster. Let me go back to the browser, and this is the vSphere lab environment in our environment, like which will be used for this demo. So this has basic networking, storage, and also the data center provisioned with it. There are multiple ESXi hosts which are added part of the cluster. Let us start the cluster creation now. Using EKS Anywhere create cluster, with the configuration file, the cluster creation is triggered. As the cluster creation process starts, a series of validations are performed, validating the configuration provided by the user using native vSphere CLI to alert if there are any inconsistencies like authentication issues, overlapping IPs, etc. Once the checks are complete, a temporary bootstrap cluster is created on the admin machine, followed by installing the components on the bootstrap cluster. After the bootstrap cluster is ready, creation of workload cluster is triggered, which is created as per the configuration provided by the user. And this is the end cluster, which is used for deploying customer workloads, and at the same time, it can manage itself using custom resource definitions installed on it. As you see here in this step, the cluster management entities are moved from bootstrap cluster to workload cluster, making it self-sufficient to operate itself. Once the workload cluster is ready, the bootstrap cluster is deleted. With this, the cluster creation is complete. Let me go back to the vSphere UI. And if you go to the VM section here, and as I have provided the folder to be EKS demo, it created the whole cluster components here in this particular folder. I have control plane nodes, etcd nodes, and the Kubernetes nodes as part of the cluster deployed on VMware now. Going back to the terminal, a directory with cluster name is created in the path where the create cluster command is performed. Users can get the kubeconfig file to access the cluster from this folder. With this, a fully functional and conformant Kubernetes cluster is ready to host workloads. As you see, the VIP configured in the configuration file fronts the HA control plane. Listing the nodes, we see 3 control plane nodes and 2 nodes in the cluster as configured. Control plane components, Cilium for CNI and vSphere CSI driver for storage are deployed in the cluster. As we list the CRDs, we can see multiple cluster-related custom resources are configured in the cluster. With these, the cluster can be managed. For example, querying the cluster's custom resources provide the cluster name, and describing the same shows the cluster configuration that was provided and the status of the cluster. Similarly, the machine's custom resource show the infrastructure VMs on the vSphere. Now, deploying a sample application to check the functionality. As you can see here, I can start deploying my workload applications or workload pods or workload deployments in this EKS Anywhere cluster. Now, moving on to GitOps. Let us see how we can manage the clusters using GitOps. As the cluster is configured with GitOps, the automation creates a private repo in the account provided and installs all Flux related components in the cluster. As you can see, the Flux system namespace holds multiple Flux related entities, and also the cluster is provisioned with all the custom resource definitions that Flux offers today. So going back to the terminal to see what exactly the repo looks like. So this is the repo which is created in my Git repository as a private repository where it is named after the cluster name. So if you go to the EKSA demo cluster, these two entities are the initial entities created by the GitOps configuration, where EKSA system includes the configuration spec that you used to create the cluster, and the other folder, Flux system, includes all the Flux components which are installed on your cluster. That means you can even control the Flux components on the cluster using this GitOps repo. Moving back to the terminal, now as part of the install, the Git repo is cloned to the cluster folder. As you can see here, you can find a Git cluster folder, and as seen here, the initial commit involves two directories, EKSA system, which contains the cluster spec, and the Flux system, which includes all deployment manifests of Flux components. Users can query the Git repository CRD to get info on the latest commit the controller had fetched. Now, changing the node count from 2 to 3 in the cluster spec in the Git repo and committing the same. As you can see, I'm using the EKS a cluster.yaml file and going ahead and changing the worker node count from 2 to 3. As you see, the nodes in the cluster as of now are 2. Committing the change that I have performed to the Git repo now. Once the change is pushed, the reconciler, the controller automatically polls for the latest commit IDs. As you see, the controller has fetched the latest commit ID, which included our change of increasing the number of machine count to 3. As you can see now, the kubectl get nodes output shows a not ready node, which is about to be provisioned. Now you can see 3 nodes which are added to the cluster. This shows that we can horizontally scale EKS Anywhere cluster using GitOps. Similarly, vertical scaling can be performed. This way, we can manage the cluster using GitOps. Apart from the cluster management, users can use the same GitOps repository to deploy their workload applications. They can deploy using Helm provided by Helm controller or standard customization based install with the Kubernetes manifest. Deploying a sample application with service type load balancer here to see the functionality. This is a sample application with a folder named after the namespace demo application with a customization file that includes 3 resources, namespace, deployment, and service. Once the demo application folder is committed, the application will be deployed in the cluster as soon as the GitOps controller gets the new commit information. Going to the Git repo now after moving the demo application folder to the Git folder. As you see, I'm adding the demo application to the Git and committing the changes. Once this change is pushed, you can see all the applications related to the demo application deployed in the cluster. As you see now, I don't have a namespace called demo application or any applications or any application pods running in that particular namespace. Pushing the changes to Git repository now. Once the controller gets the latest commit ID, as seen here. The application is deployed on your cluster now. With this, we can see how we can use the same GitOps infrastructure to even handle your application workloads. And if you observe here, I'm using the external IP with service type load balancer. Here, I'm using KubeWeb, which is one of the example third-party tools integration provided by EKSA. Let me step back to the browser to talk a little about the cluster integrations today. So EKS Anywhere provides example third-party tools which can be embedded with your cluster to deal with ingress, monitoring, service mesh, etc. Also, EKS Anywhere has a rich partner set where users can use various partner integrations to manage and operate their clusters or to extend the flexibility of using the vibrant ecosystem of Kubernetes. Let me get back to the terminal. Here, I am using KubeWeb, an example implementation that EKS Anywhere documentation provides. So I can curl the application using my external IP here. You can add the integration seamlessly as you do with any other Kubernetes platform today. Okay, with this, we have a fully functional cluster and we were able to deploy some workloads on it. Now, users can use EKS Connector to connect this cluster to EKS console to have a single pane visualization with your other cloud-based EKS clusters. Let me go back to the terminal. So if you see the EKS console of the AWS, there is a new option called register under add cluster. So if you go to the register cluster option, here you can provide a cluster name and select a provider, or you can just like go ahead and select other for general specification. And you can use an IAM role, which is required for the connector agent to work, and then say register cluster. With this, you can download a YAML file. This is not tied to EKS Anywhere, but can be used with any Kubernetes platform running on premises or on other cloud providers. Users can use the console or CLI to create the connection. From the UI, when the cluster is registered, it provides a YAML file with all the components and configuration required to deploy these connector agents on your target cluster. This can be readily deployed on the target cluster. So moving back to the terminal and see how this works. So now I have the EKSA demo cluster, which is created on premises in my VMware vSphere environment. So I have gone ahead and from the UI, I said like I want to register a cluster and got the YAML file, which is provided by the AWS console. So this is the YAML file that I have procured from the console that we have seen earlier. This has all the information about the connector agent proxy, which will be used to connect your Kubernetes cluster to EKS console securely. The other important thing here is you can manage the RBAC, allowing the accessibility to specific users who can see specific components on your cluster using the same ARN construct of your IAM user on the AWS. So here, the cluster and cluster role binding uses verb impersonate so that like a particular user, whenever he queries to see the resources, will be impersonating the same user as the IAM user on your AWS cloud today. So you can go ahead and install this particular YAML file or apply this YAML file in your cluster. As you can see, it creates multiple entities which are related to EKS connector. And listing the objects in the EKS connector shows that there are two EKS connector pods created in the EKS connector namespace. These are essential for maintaining the secure connectivity to the AWS Cloud EKS console. Let me go back to the AWS console and see what happened like after I deployed or applied this particular YAML file. You can see that like I have a EKS demo cluster 1 now saying the status active, and I have another cloud-based EKS cluster even running in the same console. This is how you can get a single pane visualization view. So this one is running in my cloud, and this is totally running on premises in my own data center. If you select this particular cluster, in the overview tab, you can see the nodes which are part of this cluster. So here we are directly connecting to an isolated Kubernetes cluster running in your environment. As of today, this is only for visualization. So you can drill down to the node level and see the information on the nodes, the resource allocation on the node, and the pods which are scheduled on this particular node, and other node related information such as annotations, labels, and taints. Here, you can further drill down to the pod level and you can see the containers running in the pod, the environment variables, the mounts, and other specific components of a container. And also, you can have a raw view of this particular configuration, which provides a JSON-based view of your Kubernetes object. And in the clusters tab, you can select the cluster, and in the workloads part of this particular section, you can filter your workloads based on the namespace or filter workloads based on the name or the type. Ending the demo part now, and over to you, Lichan.
Thank you, Gaku. Let's go to the next slide. Now that we have seen what is available in the EKS Anywhere package out there today, let's take a look at what we will add into the package in the future. EKS Anywhere entered general availability on September the 8th this year. We will dedicate the remainder of this year to focus on adding more tools and improving existing tooling for cluster lifecycle operations. We will update the EKS Anywhere architecture to include a long-lived management cluster that will in turn provision and manage one or more workload clusters. This should help you reduce the time to create a single cluster, as well as help you apply cluster operations at scale. We're also going to add more improvements to the existing diagnostic tooling and give you a new tool for pre-flight checks, which should iron out all of the prerequisite issue from your infrastructure before you deploy EKS Anywhere. Entering next year, 2022, we will release more toolset integration, starting with networking, added the much needed ingress controller and load balancer. Following that, we'll add more tools for observability as well as manageability. In addition to that, we're going to expand the range of deployment targets you can deploy the EKS Anywhere clusters to. We'll add bare metal support and cloud stack support. We're also going to look at even more deployment targets beyond these two. And we will also have more operating system and vSphere versions for your choice. Last but not least, we're going to enable EKS Anywhere subscription in the China region. As of now, any customer from any region can download the open source EKS Anywhere package and install it in your on-premise location. What we're enabling here is the purchase ability for EKS Anywhere subscription to be available in the China marketplace. Let's move on to the next slide. Now let's take a look at all the options that is available for you to run Kubernetes using EKS. We offer you a spectrum of options. If you want to run Kubernetes in the AWS cloud, we highly recommend you to use the EKS service, which gives you a fully managed service of the entire stack. If you need to run the cluster in your on-premise location, you have the choice of EKS on Outpost, EKS Anywhere, and EKS Distro. If you prefer a managed Kubernetes control plane, EKS on Outpost would be the option for you. If you need to run the cluster on your existing hardware, then it's best to look at EKS Anywhere or EKS Distro. Now, again, between these two, the difference is EKS Anywhere includes EKS Distro, and on top of that, provide you with opinionated tooling that will, one, simplify the cluster lifecycle operation, as those are the tools that we have already designed for you and implemented for you, so you don't have to do those work to deploy a EKS distro-based cluster. And two, more importantly, these tooling are going to have AWS commercial support for you to purchase. Let's move on to the next slide. With that, it brings us to the end of this session. If you want to find out more about EKS Anywhere, don't forget to check out the documentation from the website that Gokul has previously showed you. And we also have a EKS Anywhere Getting Started page on Amazon.com, where we centrally collect all of the learning materials, such as blogs, workshops, and videos for you to further learn more about EKS Anywhere. If you need to know what kind of tooling from the ecosystem you can use with the product, you can also check out the partners page from EKS Anywhere product pages. This is the end of the session. I hope you enjoy this session. Thank you.